Hello everyone and welcome to another session on CodeVita that we're going to do today. This question was asked in CodeVita 2019, that is CodeVita Season 8. The name of this question is called Dining Table. So it was there in Season 8 Dining Table. Before I proceed, we've been doing a few CodeVita questions. So just to get you all up to speed, CodeVita is TCS's annual coding contest. It consists of about 6 questions. You can find all of the details on their website on campuscommune.com. We are going to be covering a few free questions of CodeVita. We have many more such questions on our platform, but we're going to be covering a few free questions on YouTube. And if you want to keep getting the notifications, please subscribe to this channel. Do share this video with any of your friends who are preparing for placements and have not heard about us. And yeah, please like the video so that more and more people come to know about it. Okay, so just coming back to this question. And yeah, I'm going to be solving this question on the Edyst platform. So that's what I'm going to be doing right now. Just give me a minute. Yeah, I'll just open it up on the Edyst platform as well. But if you want to actually find out where this question is, you can also go to this following link. So let me just, one second, give you that link as well. Hold on. Yeah, so yeah, this is the link for all of you. So if you also want to find out where you can get it, you can follow this link here. So that's bit.ly/Edyst-CodeVita9. So that's for CodeVita Season 9. We have more than 100 plus of previous year's challenges, and we have mentor support for you. So if you're stuck, you can always ask the mentors or post on the forums, and we'll be there to help you out. So yeah, just log on to this link, and once you go to this link, this is the page that will open up for you. This has all of the information about CodeVita that we are aware of. Obviously, TCS has the most updated information about that. If you want to know more about how to start preparing for CodeVita and what actually happens, just go to the Edyst CodeVita playlist that's already mentioned in the video below, and you'll get a lot more material on about what exactly is CodeVita. If you just want to try out some of the free questions that we have, you can click this try one free module, and that should open up this page for you. So that will open up this page for you, this one, wherein this first module is free for you to go ahead and check. The other modules are paid, so you can open and unlock them and pay and unlock them. Today I am going to be solving this question over here in the math section. In the math section, if I go down, there's this question called CodeVita 2019 Dining Table. So this is the question that I am going to be solving for you. So without further delay, let's actually get started on this question. So in this question, what happens is we said that there's a conference, and the conference, some people are invited to sit down for dinner. So just how you would in a conference sit down and make arrangements for how people sit down and have dinner and so on. Now the question here is there are round tables, and they are round tables, so that's key. So there are round tables and n attendees. Okay, and what we have said is if there were exactly the exact number of tables for attendees, then we are good to go. So for example, if there are 5 attendees and there are 5 tables, each one of them sits in their own table, right? So everybody is happy. But if they are not, then we have to divide them in such a way that we make it the most equal possible. What do I mean by this? So for example, r is equal to 2 means that there are 2 tables, right? And there are 3 people possible. Now n is equal to 3 means 3 people. 3 people you can't really divide amongst 2 tables unless you cut one person in half, which is not advisable. So what you really have to do is keep 2 people on one table and 1 person on another table, right? Now, how many are the number of arrangements that you can do keeping 2 people on one table and 1 person on another table, right? You could keep 1 and 2 together, you could keep 1 and 3 together, you could keep 2 and 3 together. Now, remember we said that it's a round table. Because it's a round table, 1 and 2 is the same as 2 and 1. So for example, if you place 1 and 2 together, it's the same thing as placing 2 and 1 together. So we don't worry about, oh, I did 1, 2, now should I do 2, 1? No, don't worry about that because they are one in the same thing. Similarly, 1 and 3 is the same as 3 and 1. So really what we are saying is we have to pick 2 numbers from 3 numbers, right? So if you remember your permutations and combinations, that's 3C2. We want to take 3 from 3. I'll take 3C2, and 3C2 is nothing but 3. So I have 3 such possibilities. And for each of them, I have to also fill the remaining table, right? Because there are 2 tables. So one person will be sitting lonely, and that person could be 3 or could be 2 or could be 1. whoever it is, the point is there are 3 such combinations. So again repeating, R is the number of tables, N is the number of people. Let's look at another example that's given to us, right? And so the example given is 2, 5. 1 is the number of test cases, and 2, 5 tells us 2 is the number of tables and 5 is the number of people. So let's look at how we'll go about dividing it, right? So let me just bring it up the slides. So let's say, for example, 2, 5, right? So what we can do is, there are 2 tables, right? And there are 5 people. We'll put 3 people in one table and 2 in the other table. Is this the only configuration possible? We could have done 1 in one table and let's say 4 in other table, right? But what they had said was try to keep it as equal as possible, which means that the difference between these numbers, these tables should not be much. Hence we stuck to 3 and 2 and did not go to 1 and 4. We didn't even go to 5 and 0, that leave one table empty. We didn't go for that, right? So now there are 3 people on one table and 2 in another table. Let's look at another example. Example is 3, 9. That is, there are 3 tables, 9 people. Very easily you can put 3 in each table. Now the question comes, if we are placing 3 people in one table and 2 in another table, what are the number of ways in which we can place these people, right? And so if you do a little bit of maths, this is what you'll get. You have to choose for 3 people, you have to choose 3 people from 5 people, right? So that's 5C3. Remaining you are left with 2 people. And from those 2, you're supposed to choose 2 people. The only way you can choose 2 people from 2 people is 2C2, which is 1. So 5C3 is 10, 2C2 is 1. So there are 10 total ways possible, right? And does the question agree with us? Yes, it does. So if you just go back to the question, this is what the question says, that these are all of the possibilities that we can have from 5C3, right? We can have 1, 2, 3 together, 1, 2, 4, 1, 2, 5. Basically, how many are the ways in which you can choose 3 people from 5 people totally? That is 5C3. And the remaining 2C2, how many ways are you can choose 2 people from 2 people? There's always only one way. So we chose from 5, we chose 3, and then the remaining we placed over here, right? Hence there are 10 ways over here. So again the question is reaffirming that because we had 1, 2, 3 and 4, 5, we do not take 2, 1, 3 and 2, 3, 1 because it's a round table. So it doesn't matter to us as such over here, right? Okay. So now just coming back to our slides, this quickly, whenever you see a question like this, quickly it has now become a mathematics question more than a coding question. I mean, coding is nothing but mathematics in most senses, but it's now become more of a maths question than a coding question. And now you have to very carefully, anytime you have a permutations combination, you have to very carefully count properly. You have to figure out how many numbers and all of that, right? So let's look at a few more examples. The best way to do that is by taking more examples and understanding, right? So let's, for example, take 4 and 10. In 4 and 10, what's happening? We have 4 tables and 10 people, and we need to divide 10 people amongst 4 people, 4 table, divide 10 people amongst 4 tables such that it is equally divided, as equal as possible. Well, the easiest way is first you divide 2, 2, 2, 2. So this is, you start by doing 2, 2, 2, 2, right? So now everybody is equally divided, which means that there are 2 more people left. So in any one of them, you can just place as 3 and 3, right? So I'll put 3 people here and I'll put 3 people here, right? So now we have 3, 3, 2, 2, right? This is one way in which you can, and this is the best way in which you can equally place people. So what we are coming to finally is, and how many are the number of ways? So before we come to calculating this fully, let's come to number of ways. We have 10C3, that is choosing 3 people from 10. Then in the remaining table, we are now left with only 7 people. So in the next table, we are supposed to say 7C3, that is in this particular table, how many people are possible? We are left with 7 people because we already chose 3 people over here. We're left with 7 people. So we choose 7C3. Then now we want to choose 2 people from how many people remaining? We chose 3 here, 3 here. We are left with 4 more people. From 4 people, we want to choose 2 people. And then from the remaining 2 people, we want to choose 2 people. When you calculate this, it becomes there are 25,200 ways of seating people. Next time you sit in your college lunch cafeteria, do remember how many ways people can sit together, right? Yeah. So this is how you will go about calculating. So now, again, as I keep saying, CodeVita is all about dividing the question down into smaller and smaller problems and solving those smaller problems. Automatically, now we have 2 parts to the problem. And if you don't believe me, just go watch all our previous videos. We have, I don't know, a lot of CodeVita videos. The link to the playlist is given below. Subscribe to the channel, don't forget that, so that you get the notifications for upcoming videos. But most of the CodeVita easy questions seem to fall under this particular pattern, which is how do I create, divide a question into multiple problems. So let's have a look at the problems that we have over here. We have to divide the attendees amongst the tables in the most equal way possible. So that's the first thing we want to do. Second thing we have to do is we have to multiply the combinations of each table. So once we figured out the configuration of the table, so that's like for 10 we got 3 3 2 2, for 5 and 2 we got 3 2, and so on. Once we figure out the configuration, we want to figure out how many tables, how many combinations are possible for each configuration. So as always, we'll attack each problem one by one. Let's first attack the problem of dividing the attendees amongst the tables, right? So let's look at that problem. There are, basically speaking, there will be two types of tables, right? There will be type 1 and type 2. What do I mean by this? If you want to equally divide, right? So just make this observation with me, okay? Let's say I have 10 people, right? So I have 10 people, right? I have 3 tables, right? Or rather I have n people, right? And I have 3 tables, right? I will be able to divide n equally into 3 if n mod 3 is equal to 0, which means if n is a multiple of 3 means I will be able to divide n equally, right? So division is equal. If not, then what I will have to do is I will have to add 1 only to each number. What do I mean by this? Let's look at this, right? Let's look at 10 and 3, right? First I did 3 3 3 and then I just add 1 to this one, okay? If I had 11 and 3, I would have added 4 4 3, right? And if I had 12 and 3, it would have been 4 4 4, again equal, which means that at any time a table will exceed another table only by 1. We will not have any exceeding apart from that, right? Because if the exceeding was apart from that, then we could have distributed it further. For example, let's say this is 5 3 3. So sorry, 5 3 3. This is not the most equal way. The most equal way would have been 4 4 3, right? Or you might say, well, we could have had 6 5 3. Well, 6 5 3 is not really the most equal way, because 6 5 3, 6 plus 5 is 11, 11 plus 3 is 14, which means that actually the better way would have been 5 5 4, right? Does it make sense? So at any time we have two types of tables, one which is full to, let's say, some number, and another which is full by plus 1 of that number. This is pure maths. Just try it out with a few more numbers, you'll get it. It's because if each of the numbers are equal, then they're equal. If there is something remaining, we try to divide it amongst each table as possible, right? So again, take a pen and paper for this question. I really urge you, take a pen and paper and then only solve this question. If you solve it like a maths question, you'll be able to solve it very quickly. If you are just watching me solve this question, you'll feel like, wow, what happened? But you won't really understand the solution fully. So take a pen and paper and follow along over here. So there will always be two types of table. One table which has a certain number and another table which has plus 1 of the number. It might happen that all of them are equally divided, in which case the one of the types will be 0, right? We will not have as many of those tables. So now what we are saying is, in one of the types we'll have n by r plus 1 attendees, right? So in type 1, this is what we'll get. We'll get n by r plus 1 attendees if that's what we'll get, right? So this will be in the type 1. In type 2, we'll get n by r attendees, which means let's say there are 12 people, right? 12 people, and there is sorry, let me do it like this way. There are tables, so the tables are 10 and there are 12 people. Well, n by r integer division would be 1, so all of them get 1 1 1 1. This is 5, right? So we have 5 here and 10 people. So and we will do 2 and 2. So there are two types of tables here always. Type 1 table, which is n by r plus 1, which we have over here, and the n by r tables are these remaining ones, right? Obviously there will be one case where you won't get this, where there are 12 tables, right? So this becomes this is, which will be like this. So in this case, the type 1 tables, if it existed, would have been this, but none of the type 1 tables will exist, okay? So there are two types of tables, type 1 and type 2. In the type 1, there will be n by r plus 1 attendees. In type 2, there will be only n by r attendees present over there, okay? So this is the first thing, get this in your head and understand this one. But how many type 1 tables will be there and how many type 2 tables will be there, right? Again, this is a little bit of maths, but what we actually get is type 1 tables, there will be n modulo r type 1 tables, which means we'll first divide equally n by r, and then the remainder, we will try to divide one by one amongst all of the remaining tables. So the remainder of the tables will be n modulo r, which we will term it as x, right? So there are x type 1 tables and y type 2 tables. Now this is the beauty of here, okay? What is n minus n modulo r, which is nothing but n minus x. Basically, there are n modulo r x tables, n modulo r type 1 tables means that n minus x is y tables, right? Now again, let's go back to our thing. If there is 10 and 12, right, or let's take a smaller number, there are 3 tables and 9 people. No, sorry, there are 3 tables and 11 people, right? So 3 tables, 11 people, right? Which means that how many type 1 will we have? Type 1, we are going to have 11 modulo 3, which is 2. We'll have 2 type 2 tables, and then 11 minus 2. Right? Is that what we are saying? One second. Yeah, sorry, it should not be n minus n modulo r, it should be r minus n modulo r. So because r is the number of tables we have. So r minus n modulo r will give us 3 minus 2, which we'll have 1 type 2 table. So type 2 will be 1 table, right? So we'll have only 1 table, which is a type 2, right? So r minus n modulo r will tell us how many are the remaining tables that we have, right? Then that will be y. Now assuming there were 3 tables and 12 people, we say n modulo r is 0, so we have 0 type 1 tables, which means we have only type 2 tables, which are 3 tables, right? Which means that if it is equally divisible, even though in type 1 there will be these many attendees, it doesn't matter to us because there will be 0 such tables anyways in the type 1 tables, okay? I hope you understood this. I hope you understood the type 1 tables and the type 2 tables, how many there are. For shorthand, I'm making it called x and y. Please note this point in the video. You might have to come back to it. So, pause here possibly. In this slide, we have shown what is x, what is y, what is a and b. A is the number of people in type 1 tables. B is the number of people in type 2 tables, right? And so we've kept this here. We'll come back to this, but basically this will help us form a very elegant and very simple mathematical formula. And what is that formula? So this is the dividing the attendees part. So if you remember, we said that we'll divide the problem into 2 parts. One is divide the attendees amongst the tables and then multiply the combinations of each table. So right now we have done that. We have divided the attendees amongst each tables. We have found out how many type 1 tables will be there and how many people will be there in the type 1 tables, how many type 2 tables will be there and how many people will be there in the type 2 tables. We have done that part and we have stored that respectively in A, B, X and Y, right? That's what we have done. Now to get the combinations, what we get, don't get too worried about this, this nomenclature, I'll go through it one by one. What we are basically saying is, we said that there are A number of people in the type 1 tables, right? And there are B number of people in the type 2 tables, which means that, again, always take an example and understand. There are, let's say we have 3 tables and 5, okay, let's give an example as per the question. We have 2 tables and, actually I'll make it 3 so that we can follow. 3 tables and 5 people. How would we divide it? 2, 2, 1, right? This is how we would divide it. The 3 tables, 5 people, 3 tables, 5 people. We would divide it like this. So over here, how many people are there in the type 1 tables, which is A is equal to 2, right? How many type 1 tables are there? This is nothing but X, which is there are 2 such tables, right? B is 1, which is how many people are there in the type 1 table type 2 table, and how many people are, how many type 1 tables are there. So the type 1 tables, which is Y, is equal to 1 over here, right? So what we have to do is, here what we said was, what we're going to do is, if there are going to be 2 people in the first one, so if there are going to be 2 people in the first one, we'll do 5C2 into 3C2 into then we are left with only 1, so it will be 1C1. That's what we are going to do, right? That's exactly what I have tried to translate over here, right? We'll take NCA, which is from N, we are first going to place A people in the first table, right? A is the number of people in type 1 table. So NCA into N minus ACA, which is N minus 5 minus A is 3, 5 minus 2 is 3. So the remaining people, I placed A people, then I'm going to place N minus A people, then I'm going to place N minus 2A people, and so on. How many such will I keep going until I have x terms. X is the number of tables possible, right? So I'll keep doing this till I get x over here, right? Now imagine after all of this, I am left with m people. Like over here, after 5, 3, I'm left with only one person, right? So I'm left with one person finally, right? If I'm left with one person finally, what I'll get is I'll do or m people finally, I'll try to find out how many in the remaining table. So mcb, then I take the remaining after that m minus bcb, m minus 2 bcb, so on. I'll have y terms, that is the number of people in the type 2 tables, right? I'll have that. Then we should multiply 1 and 3 and to get the answer. So these are the number of people in the type 1 tables, these are the number of people in the type 2 tables. I multiply both of them, I will get the combinations, all the combinations possible by multiplying 1 and 3 to get the answer. The question relies heavily on, so again I'll just go back here. We find out how many people are there in the type 1 tables, how many people are there in the type 2 tables. So that number of people in type 1 tables is A, type 2 tables is B. And we find out how many type 1 tables we'll have, how many type 2 tables we'll have. That's what we are doing here, right? Again, pause the video at these 2 slides to really go through and understand what's happening here. It's not too complex, but if you're just following the slides, it will be difficult. Take a piece of paper, take pen, and then you'll follow along. You'll find that it's really not that difficult. The question, as I was saying, take a pen and paper and solve. The question isn't that difficult. The thing is, as I was discussing last time, we should always divide this question up into different parts, and we actually did divide this question up into different part, which was sorry for this. So yeah, when we divided this question into different parts, this was the dividing of the parts. 1 second. Yeah, dividing the attendees amongst the tables and multiply the combinations of each table. One thing that I did not mention here, which again we'll have to do, is calculating NCR, right? So calculating NCR, that is calculating the combinations. Here you can apply certain optimizations, and I'll tell you what those optimizations are. But calculating NCR is one of the other things that TCS CodeVita really likes to do. They really like to ask you to calculate permutations, combinations, and so there are some special ways into calculating this. In this question, you did not really have to calculate in the special ways, but we discuss all of that in our course, in the CodeVita course. So do sign up for that. You will get more details over there about how you can calculate under a modulo using Fermat's theorem and so on and so forth. Now, what I am going to do at this point is just show you my own code for this question, right? So just give me a minute. Let me just pull up my own code for this question. Yeah, and I'll show you how I ended up calculating NCR, right? So let me just go back to the question again. Yeah, so when I go to the question, right, I'll come to this part one by one, but one thing you will notice in the question is the constraints, and the constraints are always very, very helpful, right? So please never go around without reading the constraints if it's mentioned in the question. If it's not mentioned in the question, then don't worry about it. Now it says n can be maximum 20 and r can be maximum 10. So the maximum NCR that you'll have to calculate is 20C10. Remember that calculating NCR requires you to calculate the factorial. If you're going to calculate the factorial and there are only 20, the maximum factorial you have to calculate is 20 factorial. Don't miss this opportunity. Actually just hard code the values of 20 factorial. What do I mean by that? I'll show you. I wrote a function called factorial, which I'll call again and again. This is the function. And I actually defined a list with all of the factorial values. So results is this: 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 6, 24, 120, 720, and so on. How is this possible to do? Well, you have access to your own personal browser, sorry, your personal compiler and CodeVita. It's not a proctored exam in the sense that you can't copy paste. To know more about the details of copy paste and plagiarism, please watch my previous video, which is mentioned in the playlist below. But you can't really plagiarize. You can use values from your own local compiler. You can calculate all of the values till 20 factorial, which is what I have done here, calculated all of the values till 20 factorial, right? So that next time when I want the factorial, I don't have to calculate it. I can automatically pick it up here. So the order reduces over here, right? So that's what I've done, calculated all the results and results of I. So that is, if I pass fact 0, it will return 1. If I pass fact 2, it will return 2, and so on. If I pass fact 20, it will return this huge number. The second thing is, I have done this in Python. Python doesn't really have the concept of the maximum value of an integer, that is an integer being too big and all of that. It doesn't have. If you are doing this in C++ or Java, just use long type of values, or even big integer in Java if you need to, although you won't need to, but just saying, just be very sure, because it's 20 factorial, it will not fit in an integer. That's the only thing I want to say. Right now, this is how I've calculated NCR. Again, a little bit of this optimization. If n is equal to r, or r equal to 0, that is if like you have like 10c10 or 10c0, both of those cases it's 1. Don't even bother doing anything, right? So take 10c10 or 10c0, it's 1. Otherwise, if r equal to 1, then return n, which is like 10c10 or 10c0 is 1. 10c1 will always be 10, right? So if r is 1, then don't even bother doing this. You will just return 10 over there. In all other cases, fact n and fact r, right? Find fact n, which is, if you remember your NCR, it is n factorial by r factorial into n minus r factorial. So this is what I've done here. First divided by r, and then divided that result by factorial of n minus r. I could have, I know a lot of you might be thinking, you know what, I could have done this. I could have done fact of n minus r here itself, right? Why did I not do that, right? The reason I didn't do that is that this number could have been very big and might have caused an overflow, even for Python, right? Could have just caused a very big overflow here. I don't know, may have, may not have. So for example, here I could have got, let's say if it was 20c10, I would have to calculate factorial 20 divided by factorial 10 into factorial 10, which is a huge number. I don't want to go and calculate that. Better than that would be calculate factorial n by factorial r, reduce the number, and then calculate that, divide that by factorial n minus r. Again, it's the same result, but I have stopped some overflows over here. So these are some tricks that you should pick up along the way when you are doing any all these coding contests. Don't risk any overflow methods and all over here, right? So yeah, that's what I've done. This is how we calculate NCR. Very quickly, just going through it. This is the input method. I have calculated the number of type 1 tables, type 2 tables. Initially, the combination is 1. This extra counts how many type 1 tables are there. So first, I find out all of the type 1 tables possible. And then I decrease, every time I'm decreasing by the number of type 1 tables. Then I count the number of type 2 tables possible, and every time I'm decreasing by type 2. And finally, I multiply the combinations of both and then print them over here. So that's what I get. I mean, I'm not going to go detail through the code. So if I just run it and submit it, it actually does get submitted. Great. I'm not going to go through details of the code because I want you to go ahead and solve it. But yeah, if you want the code and the tutorial, the editorial for this one, we do have it on the Edyst platform. So you can go ahead and check it out over there. And you can go ahead and try out this question on the Edyst platform yourself. So yeah, just recapping the main lessons from this one. Divide the problem into smaller parts as much as possible. Try to write good functions. Try to optimize in the functions where necessary. This factorial thing is a small hack. Factorial will always be out to get you. Factorials, prime numbers. If you can at any time get such a small number, like we got really small number here, that 20 factorial is the maximum we'll get. If you get that, oh, there will be only 100 prime numbers, first 100 prime numbers. Just take an array and store the first 100 prime numbers. It will be easier for you to solve. You won't have to again write the prime number logic. You won't get caught up in time limit exceeded issues. So these are one of the small ways you can optimize your code better. I hope you understood the question. Again, my advice is take a piece of paper, take a pen and follow along this question. You'll find that this is actually super simple. This is basically 8th grade or 9th grade mathematics. It's just when you see it in all this formula form, you might just get confused. So yes, a reminder to all of you once again to go out and check out this particular problem and the entire course of CodeVita on Edyst. We have more than 100 questions of previous year's challenges, and mentor support is always available. So do check it out. This is the best time to prepare. From the previous videos, we got a lot of I'm a mechanical student, I'm a chemical student. Can I really start doing it right now? You can do it right now. Right now is May, CodeVita is in July. There is still a good 2 months time. You can still prepare. If you delay till the end of June, in July, there will be a very tough chance to get into it. So yeah, go ahead, try this out. If you have any suggestions for any other questions you want us to do, anything else you want to cover, please put in the comments below. We have not forgotten Hack with Infi round 2. We are definitely going to do Hack with Infi round 2 videos. Keep subscribing to this video, to this channel, and share this video, and you'll definitely come to know when we do Hack with Infi round 2. So all the best to all of you. Wishing you all the best for this CodeVita for your preparation, and do reach out to us on the below mentioned channel. So you can either reach out to us on this number, which is the WhatsApp number, or you can reach out to us by email, and we'll be happy to help you. Thank you so much for tuning in today, and wishing you all the best.